as much, but I like that a lot better. This just gets you 38. You already know. But yeah, that's fun. By 4, right? Not by 2. Right? You know it's times 4, not times 2? Keep going. There's more. As many ways as you can. All right, so that was Moon Hooch's Red Sky from their album Red Sky. Came out a couple years ago, I think. I don't have the exact stuff in front of me, but yeah, dope band. Really cool to see live. A lot of times, they're from New York. A lot of times you'll again, I've never been to New York, but I suppose other people, you'll see them like the subway station playing the sick stuff. Good. One of the saxophonists attaches a traffic cone to the front of his saxophone. I'm not sure why, but it does look cool. All right, so before we get into this, we're doing this warm-up. I keep forgetting that third hour has a live stream, so I have to do everything on here. And the warm-up for today is this, right? We've got 38 times 86. 38 times 86. And I know there's a delay here, guys. I apologize. Not my not my preference, but that's what we're rocking right now. And we're trying to figure out how can we break this down to make it easier to do in our heads, right? We can do the method where we do 38 and 86, line them up, knock them down, but we're going to try not to do that. So any ideas of how we can make this different? Look at it in a different way. Not change the problem, but just rearrange it. Yeah, Cheyenne. Times 8 times 10 plus 6. Now, does this work, right? 3 times 10 is 30 plus 8 is 38. Yep, that checks out. 8 times 10 is 80 plus 6 is 86. Now, how does this make it easier? Or just you broke it up and that works too? What did you do from there to kind of show that it was the same? Or did you just break it up? That's okay. That's fine. This is good. This is really good insight, okay? Maybe not today, but eventually I'm going to show you how you can break this stuff up and actually make it easier on yourself. But this is clever. This is good. You're right. That 3 right there is in the tens column, right? So what does it represent? It represents 3 tens. Right? Same thing with that 8. 8 tens is what's really going on there. That's why we drop that 0 when we do it in that way, right? That 0 and the 3, 0, 4, 0. It's because it's really, we're talking with 30s here and 80s here, not 3s and 8s. Okay, cool. That's good. That's good. What else you got for me? Yeah.
I split up the numbers into their components, so it'd be 30 times 6 and 8 times 6, and then 30 times 80, and then 8 times 80.
30 times 6, 8 times 6?
Yes.
Okay, 8 times 6, and what else?
30 times 80 and 8 times 80.
Okay, explain where these numbers are coming from and what you're going to do with them.
I'm taking 38 and multiplying it by 6, and I'm splitting up the 30 into 2 parts.
38 and multiplying it by 6. Okay, that makes more sense. So 38 times 6. So he's taking 38 times 6. Okay. Hold on 1 second. Sorry. So we're breaking it up into 38 times 6, which is good. And then you have 8 times 6. So again, 38, the whole thing times 6. And then 8 times 6. And he's also doing 30 times 8 and 8 times 80. Is that what you said?
Yeah.
Okay. So 30 times 80 is going to be the 3 times the 8. The 8 times 80 is going to be 8 times the 8. So see how we did 3 times the 8, the 8 times the 8? That's what he's doing here. And then over here, he's doing 38, the whole thing, times the 6, and then the 8 times the 6. See, the problem here, okay, if this is 38, you've already done the 3 and the 8 to the 8. So you don't need to do the 8 to the, well, hold on, 38 times the 8. Let's keep going. So what did you do from here?
It was supposed to be 30 times 6
I was right originally. Okay, cool. And then here it's supposed to be 36 times. Is this good now? Are you happy with this? Okay, good, wonderful. All right, so now what'd you do? Add them all up?
After you multiply them by the answers, you'd add them all.
Yep, okay. So this is what he did. Let's check and see if that works. Everybody, what's 6 times 3? 18 times 10. 180, right? You guys see how I did that? 6 times 3, but it's really 6 times 30, so we have to multiply it by 10. 8 times 6 is 48. We have 3 times 8 here times 10 twice. Do you see how there's 2 zeros? So we have 3 times 8, which we already know is what? What's 3 times 8? 24 with 2 zeros in the end. And then we have 8 times 8, which is 64 times 10. And if we add all those up, we should get our right answer, right? We get 2400 plus 640. Let's add those together. That's going to be 3040. That's what these are. And then here and here, we're going to have 228, right? 20 from here gets to 200, and then 28 more gets us to 48. And then when we add those together, we're going to get 306. Whoops, not 306. 3268, which is our answer. Cool. And again, sorry for the delay. We're feeling okay? Not really. Completely lost? That's okay. That was a tough way of doing it. Okay? But it's valid. Okay? I didn't ask for simpler ways. I asked for different ways. Any other ways you want to show me? Should I get to it, Autumn? No?
Please.
Okay, I understand. So here's what I'm going to do. Okay? Here's what I'm going to do. Remember, multiplication is about groups. So this is saying 38 groups of 86, right? How about this? What if we said 40 groups of 86? That'd be easier to do, right? Now, is this number going to be bigger or smaller than this number? It's going to be bigger, right? Because it's 2 extra groups of 86. So after we get our answer, if we want to get this guy, we have to subtract 86 twice, right? Because we overshot it by 2 groups of 86. Now, why did I choose this? Well, 10s are really easy to work with, right? It's not the easiest it could be, and I'll show you that in a second, but it's easier. So what if we did 4 times 86 and then times 10? So really what we're doing is this. And we can do it in any order we want, right? It's all multiplication. So let's do 4 times 86. In fact, see if you guys can handle this. Right? It's valid. Now, when we do multiplication, we have 2 terms here, right? So everything gets multiplied. So that 4 is going to go to the 80 and the 6. You do this all the time when you use that algorithm, okay? You do. So first of all, let's do 4 times 6. What's that? What's 4 times 6? Okay. Now we're going to do 80 times 6. Or, I'm sorry, 80 times 4. 8 times 4 is 16 times 2, which is 32, with a 0 on the end, right? Can you do 320 and 24 and add them up in your head? What's that? 3, what? Then we times by 10. What's wrong? Why is this not the right answer? We're supposed to have 3, 2, 6, 8. Where did I go wrong? What did I do that was incorrect? Yeah.
You added 286s.
I added 286s. You remember. Isn't it amazing? I told you guys that like 5 seconds ago, right before we started, that it was going to be bigger than this. But a lot of you guys are like, wait, what? It's like I'm the magician, right? I structure it this way. The way I say the words and the way I order what I'm going to say, it's to mess with you. I know the rabbit's in the hat. Okay? It's great. Pay attention. I'm going to do that more today, okay? Tipping my pitches. All right, so that's too big. And it should be, you dingus, right? We got 40 groups of 86 here. We need 38. So we need to subtract 86 twice, right? Well, what is 86 times 2? 126, right? Oh, I'm sorry, 162 is what I meant. So we need to subtract 162. Don't you dare. Okay? 3440 minus 162. And we subtract it. And what do we get? Now, here's what we can do. Okay, check it out. 3440 minus 100 minus 60 minus 2. Is that the same? Right? Let's do that. Let's subtract 100 first. Danny, what's this minus 100? 3340. Very good. All right. Easy for you to say. You want to subtract the 2 or the 60? The 60. Great idea. All right. So instead of subtracting 60, couldn't I do this? Subtract 40 and then subtract 20? What happens if I subtract 40? What happens if I subtract 40? It zeroes out, right? We get 3300? So what's 3300 minus 20? 3280. Do you see how that goes away when we do zeros? Easier to think of in your head. Trust me, I know it's weird on paper. But subtracting 60 is hard because you have to carry, right? So instead subtract 40 and then subtract 20 more. Because once you get to those zeros, subtracting 20 is easy, right? Get yourself the zeros. Now we subtract 2 and we get 3278, our answer, right? What?
86 plus 86 is not 162.
86 times 2 is not 162. A couple of you guys caught that. So I just did all this, right? But now the beauty is you get to go back and do it yourself. So you've seen how I did it. Let's do it. Yes, Danny.
How come you told Zayden when you raised his hand, don't you dare?
Because he knew that I did it wrong, and I did it wrong on purpose. He's the guy in the audience that's like, it's in the hat! It's in the hat! It's like, we know! We're here for the magic. We're not subtracting 162, we're subtracting 86 twice. Guys, what is 86 times 2? Pause. That's a hard question. That's hard, 86 times 2. Better question, what's 80 times 2? 160. What's 6 times 2? So it can't be, right? 80 times 2 is 160. 6 times 2 is 12. We add them together, we get 172, not 162. That's why my answer was off by 10. So now we're subtracting 172. So here's what we're going to do. 3440 minus 100 minus 70 minus 2. What do you want to subtract first, Danny?
I want to subtract the 2.
The 2? Dear God, why?
Because it's the smallest number.
Yeah, it is the smallest number. That's going to give us a 38 here, and that's going to make things harder when we subtract 70. Right?
Yes.
Yes. Yes. Yes, Danny. Yes. All right, so let's subtract hundo, right? Now, normally when we do subtraction, right, we line it up like this, and we subtract 172, and we start with the 2. Right? We go right to left. No, we're going to subtract left to right. We're going to subtract 100 first. That makes way more sense. So we're going to subtract 100, we get 3340, which is not hard to do. Now we're going to subtract 70. Now, instead of subtracting 70, what should I subtract? I should subtract 2 numbers. What? 40 and 30. If I subtract 40, I get zeros. Okay? Now subtract 30. What am I going to get? 3, 2, what? I'm subtracting 30. Someone else. Someone else. I already subtracted 40, so those are zeros. If I subtract 30 more. Oh, I'm sorry. Tell me to scoot this up. I subtracted 40, and then I subtracted 30 more. You see how that can be helpful? It's a lot less work. The 40's free. Yeah, I know. You don't like it. You'll like it, okay? Trust me, especially when we start throwing letters in, okay? Start getting used to doing this with numbers. 3270 minus 2. What's that going to be? 32 something, right? You what?
I said this is your time, Alex.
This is 2. Yeah.
Subtract 2. Really, the answer is going to be Basically, the answer is going to be the same as if I just said 70 minus 2, right? Because it's not going to affect these guys. So what's 70 minus 2? It's going to be 60 something. What is it? Subtract 2. 8. Right? That checks out. Now, again, you're thinking, good God, why would we do it this way? Right? Let's try it again. It's not about the answer. I gave you the answer. Calculators only give you the answer. It's about thinking about things in a different way. Because if you can break it up differently, you might be able to find a pattern that wasn't there before. You also might be able to do some of the stuff in your head eventually, which is dope. Okay? So 38 times 86. Last time we rounded the 38. How about we round this one? What do you want to round that to? 90, right? Something with 0 in the end, right? So let's say this. Now, is this number going to be bigger or smaller than the right answer? Come on, it's going to be bigger, right? How many bigger? 4 38s, right? So we need to subtract 4 times 38. So really what we're doing here is this. That'll get us the right answer. Let's focus on this. We have 38 times 9 times 10. Let's do 38 times 9 first, which is really just 30 times 9 plus 8 times 9. What's 30 times 9? Yes. 270. What's 8 times 9? Well, we know 8 times 10 is 80, right? So 8 times 9 is going to be 8 less. 72. $270 plus 72. Again, you're like, why would we do all this? Focus on this. This is the problem, okay? If you're one of those people that's like, I don't see why we're going to do all those steps, this is the problem right now. How would we do this in our heads? How about instead of adding 72, which is hard, let's add 30 and then add 42 more? Well, 30 gets us to what? Come on, answer. 30 gets us to what? 300. Now add 42 more. 342. Okay? Now I want to times that by 10. Come on, everybody. That's not the right answer. Why is that not the right answer? Yeah. Because we need to subtract 4 times 38. Now, what is 4 times 38 but 4 times 40 minus 4 groups of 38? I'm sorry, not 4 groups of 38. 2 groups of 4. We have 40 groups of 4. If I take 2 groups of 4 away, then I've got 38 groups of 4. What's 40 times 4? 160. 4 times 4 is 16 times 10. 4 times 2 is 8. We subtract, we get 152. So we're subtracting 152. Danny!
Yes.
We're going to subtract 100, then we're going to subtract 50, and then we're going to subtract 2. Subtract 100.
3,320.
3,320. Subtract 50. No, subtract 20 and then subtract 30.
Are you asking me?
Yes.
3370.
Nope. Try again. Not 3.
Oh, 3270.
Yep. Thank you very much. Subtract 2. Go. 3, 2, what? 70 minus 2. 68. Check. Now, I start with big numbers, because if I don't start with big numbers, you go, why? Right? And you're still going, why? Probably, some of you guys. It's fine. Math is not about the answer. I gave you the freaking answer, okay? It's about doing things in different ways and rearranging stuff. That is where the magic happens. Rabbits in the hat. There are more ways to do this, and there's an actual easier way to break it up, but we're not ready for that yet. Let's try this. Give me a 2-digit number. Give me something interesting. Come on.
98.
98.
Why?
Give me a 1-digit number. Go. 2. Give me something more interesting. 9. How can we do this in our heads? How would you do it? Go.
Multiply 98 by 10 and subtract 98.
Do you see we have 10 groups of 98 here? So if we take away 1 group of 98, we've got 9 groups of 98, right? So what's 10 groups of 98? Good job, class. What's 1 group of 98? Good job, class. Are we going to take away 98? No, that's hard. Let's take away 80 and then take away what? 18. Take away 80. That's easy. Done. We're at 900. Take away 18. No, take away 10. We're at 900. Take away 10. 890. Take away 8 more.
Always take away 100.
Yeah.
What?
That too.
Take away 100.
Yes! Brilliant. You guys hear that? He's going to take away 100 and then add 2. Yes, that's what I'm talking about. All right, so we take away 100 and we get 880, right? But we overshot by 2, so we got to add 2 more. Ah, be still my heart. That was great. That's thinking. That's what it's all about. That's math. You guys are all laughing at him earlier because he couldn't do 70 minus 2, okay?
Real genius now.
That's what I'm talking about. Seriously. That's what it's all about. Who cares what 98 times 9 is? Your calculator knows that. You don't need to know that. But this, thinking I can take away 100 and then add 2, that is understanding. That's mathematics, not calculation. That was brilliant. Well done. Well done. Do you see how this can be useful? Or we could do it this way. 8 times 9. You have to memorize this. There's no way you could know what 8 times 9 is without memorization. What is it? Has to be 72. We have to carry the 7. Have fun with that. 9 times 9 is 81. We add the 7, 882. Okay. Good luck doing that in your head. And if you're wasting all that mental energy to try to remember, okay, I carried the 7, that's going to act as a 70. Why not do it this way? Adding and subtracting is way easier than multiplying. Now, if you didn't know 8 times 9 because they didn't teach it in elementary, and you didn't, have those time tests to bash it into your skull, right? How could you figure out 8 times 9? You don't know what 8 times 9 is. How could you figure it out?
8 times 7 is 8.
Everybody knows 8 times 10. 80. Subtract 8. 72. That is understanding. Why didn't they teach you that?
They're not as smart as you.
No. It's because your teachers are incentivized to make sure that you get the right answer, because that's what we're looking for, right? They don't give you the answer because the answer is what they're looking for. And so how do you get the right answer? You teach them something that as long as you do it the same way every single time, you're guaranteed to get the right answer. You have no idea why we carry the 7 other than we're told to. If this was a 1 here, we'd end up putting a 0 down and doing the whole dumb thing again, right? Why do we put a 0 there? I don't know. The reason is that 1 represents a 10. So when you do 1 times 8, you're not getting 8, you're getting 80. 10 times 90 is not 9, right? It's going to be a 900. But that's why. And that's just multiplication. Multiplication's like 3rd grade, man. 4th grade, 5th grade, right? Imagine all the other math that you just do because it's the steps and you have no idea why. That's what we're getting at here. That's where the magic happens. That's understanding. That's knowledge. We're going to be messing with this some more. There are infinitely many ways to do this type of problem. You can break that up as many ways as you want, as many as there are numbers, okay? The question is, which way is most helpful? And we're going to work on that, okay? All right, so put that away. Get out your notes. The notes will be in color on Google Classroom. Forgive me, I am behind on getting that posted. But I'm going to put them up on the projector.
Is your punchy hole?
Punchy old thing's back there. Yeah, it's locked. You got to unlock it. Press down, move the switch.
Are we have homework to do tonight?
No, we are not going to have homework today.
No.
I know, right? Homework is dumb. Why would anyone ever do homework? Right? We don't need homework every day. Today, I want you. Tomorrow, we're going to have homework. Okay? I hate that. I absolutely hate that with every fiber of my being.
I don't understand why you're not freezing this.
Oh, well, it's because I move around a lot. Yes. I should get sponsored by 5 Hour Energy or something. Not that I drink it, but run an ad across here.
My back hurts.
Google AdSense. I'm sorry about that. When your back hurts, everything
You
hurts.
should drink one before class one day.
I've done that before. That was interesting.
Dude, I'll do it.
This is me. I had a little bit of caffeine this morning. That's it. And I have very little sleep.
It's in the hat.
It's in the hat.
I woke up at 5 in the morning and my brother drank coconut.
I love my job. All right.
We should.
Here we go. So simplifying expressions. First of all, simplification is a dumb word because simple to you might be complex to another, right? It's very demeaning to say, oh, this is simple, right? So when I see this in math, I don't like it, but you need to know what it means, okay? What it means usually is we're going to condense, okay? We're not talking about condensation. We're talking about making things smaller, right? To condense a speech, perhaps, right? Something I struggle with. To make smaller is what we're doing. Expression. Expression is like blue kite. It's not a sentence. It's an idea. It's poetry. It's beautiful. It does not demand an answer. It just is. And that's what an expression is. It's something that doesn't have an equal sign. It does not demand an answer. It just is. It's poetic. Okay? So an expression doesn't have an equal sign. Equations do. Equal equation, right? Okay. So this is an expression. Now, expressions are made up of terms. We've talked about this a little bit, but again, trying to formalize this for your algebraic education that you totally had last year. Again, jumping from algebra to geometry, the algebra is what kills everybody every year. Okay. So terms. A single number or variable or the product of several numbers, whatever. Terms are separated by addition or subtraction. That's the winner right there. They're separated by addition or subtraction. So check it out. 1, 2, 3, 4, 5 terms. How do I know? Because there's a minus, plus, plus, plus there. They're separated. The 6 and the x to the 4th, that's one term. It's one idea. They are joined together in holy matrimony, that 6 and the x to the 4th, okay? If we want to split them up, we have to divorce them, which is division, okay? But right now they're together. They're a single term. Now, what do we have when we have a bunch of terms linked together? We call it a polynomial. Poly meaning many, like polytheism. The Romans had many gods, right? Monotheism, single god, one. So poly means many. And nomial is a Latin term for name. So we have many names. Another name for name is term, right? Like a definition. Okay? You are defined by your name. That's why names are so important in Greek history and everything, right? So we have lots of terms. That's what that means. Now, if we had one term, we call it a monomial. 2 terms, binomial. 3 terms, trinomial. After that, no one cares. Okay? But even with just 2 terms, we can call that a polynomial. Okay? It's fair. I never knew what this word was in high school because, like, who cares, right? But it's important. You should know what it means. So polynomial is an expression or an equation with more than one term. Okay? Turn the page.
Yeah.
Oh, here.
Well, it says number 1.
Trade me. Oh, yeah. The page numbers are off because I had to, like, take a bunch of algebra notes and Frankenstein them together.
Yeah, you didn't have.
So page 5 is what you want to be looking at. Now we're here, okay? So now it says simplifying expressions, combining like terms. Like terms. Are we good?
I think so.
Okay. So like terms are terms that have the same power, right? It's all about the power. So when we look at powers, we're talking about exponents. So x squared and x to the 3rd are different exponents. So they are not like. They are different terms. But x cubed and x cubed match, even though there's a 2 there and a 1 here, an invisible 1. They're like terms, so we can combine them. Think of it this way. Powers are kind of like units, right? I've got 2 x cubes. Another way to say it is I've got 2 chickens, right? Podunk, Illinois. Smell one step in? Yeah? Got it? Okay, so we got 2 chickens here. He has 1 chicken. We're adding them because they're both positive. How many chickens we got? 3 chickens. So that's 3x cubed. They can go together. It's not 2x to the 6th or something, okay? No, I've got 2 chickens, you've got 1 chicken, we got 3 chickens. That's it. X squared goes with 5x squared. If I've got 1x squared and you got 5x squared, how many x squared we got? I reckon we have 6, right? Negative 9x plus 9x. I lost 9 chickens, you have 9 chickens. It's kind of weird. We put them together, we have 0 chickens. Yes. 1 plus negative 7. Those go together because they have the same power. The power of 0. X to the 0th power is hidden there. You know what something the 0th power is? 1. If it was 0, those would be zeros, right? 1 plus negative 7 is negative 6. You would think that, right? But I'll prove to you later that it's not. Not today. So 1 plus negative 7 is negative 6. And all together, we put them up. We get rid of the 0 because it's redundant. And we have a simplified, a condensed polynomial. It's smaller, right? It started out real big. How many terms we got? 1, 2, 3, 4, 5, 6, 7, 8. Now we're down to 3. We condensed it. And it's as small as it can get. That's condensed. All of these terms are not like anymore. See how they're different colors, right? See how the powers are different? So we can't do anything more. That's it. We've done all we can. The patient is dead. So let's move on. There's only one thing to do when the patient's dead. What is it? No. Search their pockets for loose change. Turn the page. It's what he would have wanted. What you already know. Y equals x plus 3 is the same as y minus 3 equals x. You totally know that, right? Why are these the same? Yes, go ahead. You're right.
If you add 3, or like if you plus 3 to the
Nope.
minus 3.
Oh, so you're starting down and going back up? So if you were to add 3, that would go away, and then the 3 goes over here?
Yeah.
Yeah, that's valid. This is the beauty of algebra. Algebra says, as long as you can undo what you've done, it's fair. So can we move that 3? Yes, we can move it by subtraction, because if we do the opposite, we can move it back. That's algebra. So can we move that 3? Yes, we can move it by subtraction, because if we do the opposite, we can move it back. That's algebra. Now, what is going on here? Why would we do something like this? Doesn't get us a nice number over here. Well, this one we call solved for y, where if I plug the number for x, it would pop out the answer right here, right? That's nice. I like formulas that when I plug the stuff in, I get the answer on one side. Well, what if I wanted to solve for x? Well, I need x on its own, right? So I'd rearrange it. And now when I plug in stuff over here, I get a nice answer for x, right? I get whatever happens over here. And again, what did I do? I subtracted from both sides. Now, I don't think I made this joke in here. I'm going to make it now. All right, gentlemen, are you ready?
Yeah.
All right, here we go. Yeah, okay. So here's the deal, right? Algebra says, okay, algebra is all about what is legal and what is not. This is child abuse. That's not legal. But if you do it to both sides, algebra says it's totally fine. Okay? Isn't that beautiful? It's such a better world for me to live in. All right, so as long as you do it to both sides, it's all kosher. So as long as we subtract 3 from both sides, it's going to be fine. Now, when we move terms, how many terms do I have right here on this right side? How many terms do I have right here? Oh, hold on. Wait for my finger to show up. And there it is. How many terms do we have right here? 2 terms. Okay? So we have 2 terms. If I want to move the 3, that's moving a term, right? When we move stuff, okay, focus up here. When we move stuff, listen to me. We do not multiply or divide. We do not root, we don't square. When we move stuff, we add or subtract. It's that simple. That's all we do. Add or subtract when we move stuff. The 3 needs to be moved for the x to be on its own. So I subtract it because it's already positive. We don't divide, we don't multiply. It's simple. When you want to move stuff, you subtract or add. I'm moving a term. When I move terms, I subtract or add. Yeah, this delay is getting really bad. All right, so if you look down here, all right. So if you look down here, okay, I show you the work I did. We can write it as x equals y minus 3. Now, why is this, y minus 3 equals x, the same as x equals y minus 3? Why are these two the same? Yeah, that's right. You're right. Why are these two the same? Yeah.
It doesn't matter which side you put.
Is it true to say that 3 plus 5 equals 8 and 8 equals 5 plus 3?
Yes.
It's true forward and backwards. It's a property of equality. The left side equals the right side, therefore the right side must equal the left side. So I can write it either way. Left equals right or right equals left. We don't need to move stuff around and rearrange it. You just flip them. Now, why can we flip them? Because algebra says if you do it to both sides, it's okay. Sorry, your back hurts today. Are you all right?
He's
Good.
like fall
Okay.
asleep.
I know. Yeah. So as long as you flip both, you're fine. Page. E equals mc squared. Guys, are you ready for this poetry? So Einstein's messing around with a bunch of equations, things we know, right? Gravity, all this stuff. That's already been predetermined, and the way they found that out was by testing stuff, and they came up with these equations, right? Einstein comes up with E equals mc squared. What does it mean? Well, E stands for energy, the total amount of energy. And again, scientists out there, I'm simplifying this a lot, okay? We're going with the poetry here, okay? Not the exact science. M stands for mass, the things that are inside you, what makes you matter. Okay? C is the speed of light, which is constant throughout the entire universe, more or less. Okay? Squared means speed times speed, right? It means do it times itself. So the speed of light times the speed of light. Now, when you take speed times speed, you get acceleration. That's how fast you're going, right? Like, not how fast you're going, but how fast you're changing. So from 0 to 60, how fast do you go from 0 to 60? That's acceleration, right? If you're going 55 miles per hour, that's speed. Speed is constant. What are you doing right now? 55, right? How fast are you accelerating? Well, I'm accelerating 2 miles per hour, right? I'm going up 2 miles every hour. That's a very slow acceleration, right? So we have acceleration of light times mass equals energy. What does it mean? Here's what it means. It means if you take all of the particles inside you, the mass inside you, things that make you matter, what makes you matter, and multiply it by the speed of light squared, you get all the energy that's contained within you. For you, a rock, a mountain, a tree, anything. a star. We are made of light. You take what matters and you put it together with light, and you get the energy within you, what makes you you. More or less. Okay? That's the beauty here. Now, imagine you're Einstein, messing around with equations, trying to figure out stuff, a relationship between energy and matter. And boom, the speed of light squared pops up. He didn't put that in there. It's like, oh, it works, right? Like, I think that's it. No, it came up naturally. The speed of light is a constant. It's a number. And that number appears. And he knows what it is because he's Einstein, right? He studies the universe. He knows what the speed of light is. It's within us. How crazy is that? Just shows up out of nowhere. The question is why, right? See you next time.
Class started.
Yeah, Mr. Mac.
That's right. Like and subscribe. Ring that bell. Leave a mean comment.
Hey.
Cancel my stream.